Okay, let's look at simple problems how to find equilibria and also their stability. Let's look at an example over here. First of all, an equilibrium means you have a constant solution to a differential equation. So we are looking for a constant solution. We are looking for a constant solution. And that means you have y star is equal to a constant. So some kind of constant. That's why it's called an equilibrium solution. And for this equation over here, we can easily see that y1 star equal to 0 and y2 star equal to 2 are two so-called constant solutions over here. We can easily see, for example, if you look at this one, 2, if you take the derivative, it's going to be 0, and on the right hand side is 2. 2 minus 2 is equal to 0. So-called equilibrium means the solution is no longer changing with respect to the independent variable over here is x. Usually we use time t. Okay. So in general, suppose you have a differential equation called y prime is equal to f of y. Okay. How to find equilibrium? Equilibrium means f of y star is equal to 0. Okay. So for this problem over here, we have the following. So we have y2 minus y equal to 0. Then we solve two solutions. Y star 1 is equal to 0 and y2 star is equal to 2. And what do we mean by stability of equilibrium? From economics perspective, it means if your quantity is not at equilibrium but nearby, then after some time the quantity should approach the equilibrium. That's called stable. If it leaves the equilibrium, that's called unstable. And stability of an equilibrium can be tested using the derivative. So if you look at the derivative y prime of y, and then we will see, and take the derivative using the product rule, or you can say this is 2y minus y squared derivative, and that's going to be 2 minus 2y, right? So now you evaluate at the y1 star, you will see that this is going to be 2 minus 2 times 0, that's going to be 2, which is positive. And then it means this y1 star is unstable. If it's positive, it's unstable. And if it's positive, if it's negative, then it's going to be stable. If you look at this one over here, this is going to be negative. We have 2 minus 2 times 2, and it's negative 2, it's less than 0. And y2 star over here is stable. And this method is just a calculus method using algebra. But on the other hand, we can also see equilibrium solutions and also most of the time the stability by using geometric method. And here is the geometric method. Here is algebra. So we are done over here. But on the other hand, we can illustrate this process by doing the following. First, we're going to draw a diagram of f of y. Remember, f of y is y prime, right? And how do we sketch this diagram? It's a parabola. F of y is a parabola facing downward, opening downward. So this is 1, this is 0, this is 2. So we see equilibria are zeros of this function. And then we look at the sign of this capital F of y. The value of capital F of y over here is negative, right? And between 0 and 2 is positive. And beyond 2 is again negative. Now we know what's the meaning of derivative being positive or negative. If derivative is positive, then y value is increasing. This is what we are saying. If derivative is negative, then y value is decreasing. So now we are going to add arrows to the y-axis. This is y-axis. Okay. So between negative infinity and 0, the derivative is negative, so y is decreasing. We use this arrow to indicate that y value is decreasing. And between 0 and 2 is increasing. And then beyond 2, value of y is decreasing. So now we clearly see why 0 equilibrium is unstable, because nearby values are leaving 0. And why this equilibrium 2 is stable? Because nearby values are approaching 2. So here is our conclusion, that if when x is approximately 0, if y of 0, when is at the starting time is approximately 0, then y of x as a solution is going to approach 0 as x going to infinity. So this is the meaning of, actually y of x is not going to approach 0 as x going to infinity. So that means unstable. And if y of 0 is approximately 2, near 2, and then y of x is approaching 2 as x going to infinity. And this is called stable. This one over here, in fact, is called asymptotically stable, and this one is not. This one is unstable. Okay. So that's the basic concept about stability of an equilibrium.